Now let us see the second type under partial fractions, and this case is that of linear but repeated factors. So if you see this example given, we have a quadratic term in the numerator, and in the denominator we have one factor which is x plus a, which is not repeated, but the other factor x plus b is repeated because it is coming twice, as we can see from x plus b the whole square. So in this case, the way we split the given function into partial fractions is like this. That is, for the first fraction we consider x plus a, so let's call capital A as its numerator, plus for the second fraction we consider only one occurrence of the repeated factor first, that is x plus b, and we must also consider the third fraction in which we have x plus b the whole squared, simply because in general we have to consider this expression on right hand side, which on simplified will give us the expression of the type on left hand side. So therefore we have to keep provision to consider the terms of only x plus b in the denominator as well as x plus b the whole squared, because the LCM of x plus b and x plus b the whole squared is x plus b the whole squared, right? Now suppose we compare the numerators of both sides. Here we have px square plus qx plus r given by, on the right hand side a will get multiplied with x plus b the whole squared, plus b will get multiplied with x plus a and one additional occurrence of x plus b, and c will get multiplied just with x plus a, as we know by cross multiplying and making it single term. Now here if you observe, let us put different values of x so that two terms vanish on the right hand side and only one term remains. So if we put x as minus a, what happens is this particular expression will vanish because it has x plus a, and similarly the last expression will also vanish because that also has x plus a. So by doing that we will get the value of capital A. So therefore putting x as minus a, we get the value of capital A. Okay, so the first fraction is resolved. Now what happens if we put x as minus b? If we put x as minus b, then first term will vanish and second term will also vanish because both have x plus b as one of the factors. So therefore this will give us the last constant, that is c, right? Now here we have seen that by putting x as minus a or minus b, we get the two constants a and c. So that means to get the value of remaining constant b, we have to put some other value of x, and as we have seen, this particular equation is an identity in x. So we are free to put any other value of x, that is not necessarily the value that makes a particular denominator 0. So we are free to choose any value. Say we can put x as 0, x as 1, x as minus 1 and so on. Now whichever is the value which is not used previously by minus a and minus b, so we can choose and substitute any required value, and that will give us the remaining constant b, right? So that's the way we use the linear but repeated factors in this way. Now here also let's solve one question based on this particular pattern. Evaluate integral of x minus 1 upon x plus 1 into x plus 2 the whole square. So here let us call that particular function x minus 1 upon x plus 1 into x plus 2 the whole square, as we have to write it as partial fractions. So let's call it as a upon x plus 1 plus b upon, now x plus 2 is a repeated factor, so first we consider a fraction having only x plus 2 in the denominator and the third fraction having x plus 2 square in the denominator, right? So therefore this implies x minus 1 is equal to a into x plus 2 the whole square plus b into x plus 1 into x plus 2 plus c into x plus 1, right? So now we have to successively vanish two terms so that one unknown constant remains, right? Now let's put x as minus 1. Now by putting x as minus 1, the second term and third term will vanish and we will get the value of a. So putting x as minus 1 on left hand side, we get minus 1 minus 1, that is minus 2, is equal to a into bracket minus 1 plus 2 is 1 and 1 squared is 1. So therefore here we get a as minus 2. Okay. Now let's put x as minus 2. So that will give us on left hand side x minus 1. So that is minus 2 minus 1 is minus 3. Now when we put x as minus 2, what happens is the first term and second term will vanish and we'll get the value of c, correct? So here we get c into bracket minus 2 plus 1 is minus 1. So that gives us c is equal to 3. So we got two constants. Now as we saw earlier, we have to put any other simpler value of x to get the remaining constant, because now since we know the values of a and c. So let's put x as 0 because that is easiest in calculations. So on left hand side 0 minus 1 is minus 1, that is equal to, on the right hand side 0 plus 2, that is 2 square, which is 4a, and 4 into a is minus 2 as we have already found out, correct? Plus we have b into, now 0 plus 1 is 1 and 0 plus 2 is 2, so therefore here we have nothing but 2b, right? And lastly we have c, well c is nothing but 3 and 0 plus 1, that is the last expression, that is nothing but 1. So we have just 3 there, right? Now, so therefore let us simplify this. We have 2b equal to minus 1, taking the 8 on other side, we have plus 8 and subtracting 3, so that gives us 8 minus 4, which is 4, so that gives us b is equal to 2. So we have got the values of all the three constants. So therefore our integral is nothing but integral of a is minus 2 upon x plus 1 then b is plus 2, so then we have plus 2 upon, the second factor was x plus 2, so here we have x plus 2 in the denominator, and the last constant to be found out was 3, so that is plus 3 upon x plus 2 the whole square. Right, and then we can easily integrate this particular expression. So let's integrate that. Right. Now integral of minus 2 upon x plus 1, we know that that will be log. Similarly the second term will also have the integral as log. So for the first term we have minus 2 log of x plus 1 Then for the second term we have plus 2 into log of x plus 2, 2 into log of x plus 2. And the last term is 3 upon x plus 2 the whole square. So we see it's a function of linear expression in x. So therefore that is nothing but minus 3 upon x plus 2. So that completes the final answer. So in this way we have to identify the given function and factorize it, and if it has linear and a repeated factor, then we solve by this particular method.